Okay, for this section of the test review, we're going to be talking about interpreting graphs. So in this graph, I have a graphical representation of a race between Eric and Robbie. The solid line is Robbie, so this is Robbie, and the dashed line is Eric. Okay, so I'm going to use this graph to answer some questions. So this is a time and distance graph, so the y-axis is the distance, and it's going up 200 each time I go up 1. And that's 200 meters. And then the x-axis is minutes, and it's just going over 1. So it's important to look at the scale on these graphs before you start trying to interpret them, because sometimes it's not. That's one of the biggest mistakes is they think this is 1, 2, 3, 4. 1, 2, 3. It's not just simple counting sometimes if the scale is different. This is going up by 200s each time. Okay. The first thing it wants me to figure out is how far they ran. So basically I want to see what the distance is at the very end. And it looks like they're at 1,600 meters. So their distance is 1,600 meters. Okay. How long does it take, or how long does the race take Eric? Eric is the dotted line. And it looks like he hits 1,600 meters at 9 minutes. So 9 minutes would be the answer. How long does it take Robbie? Robbie is the solid line, and it looks like he hits 1,600 at 10 minutes. So 10 minutes would be my answer. Not too tough, right? How long, or what does Robbie do from minutes 4 to 8? So Robbie is a solid line. So at minutes 4 to 8, that's right here, this chunk of time right there, I'm going to look at Robbie's solid line from 4 to 8. And it looks like it's flat, right? Which with time and distance, that means he's not going further ahead or coming back, right? So if he's not moving ahead or back, he is standing still. Maybe he got tired, needed a breather. Maybe Robbie just was, having a drink break or something, but he was not moving, right? So from 4 to 8 minutes, he is standing still. He's resting, something along that line of thought. Okay. What does Eric do at minute 3? So he's the dashed line, right? So at minute 3, I go up to the dash line, and it looks like at minute 3, it starts going down, right? So that means he's getting closer to where he started. So it looks like at minute 3, he turns back and starts going backwards. So what does Eric do at minute 3? Turns around, goes backwards. Let's say he goes back towards the start. Okay. Who wins the race? So basically we're trying to see who gets to 1,600 feet first, right? It looks like the dash line does. He finishes at 9, right? And the dash line is Eric. So Eric is the winner. Where is Eric moving fastest? So with speed and stuff like that, since this is distance over time, the steeper the line, the faster he's moving, right? And it looks like he is moving fastest from minutes 8 and 9. So we always talk about it in terms of x. So between 8 and 9 minutes. Okay, where's Robbie moving fastest? So we're looking for Robbie's steepest line. And it looks like his steepest line is going to be these last 2 minutes, 8 and 10 minutes. Between 8 and 10 minutes. Okay. Now, what is the speed of Robbie between 8 and 10 minutes? So now it's actually asking me to find the actual speed. And this is usually the thing that students struggle with the most, so pay attention to this part. So to find the speed is always set up as distance over time, right? Like miles per hour. So this is in meters over minutes. So all I have to do to find the speed is I'm going to find the slope of that line right there. It looks like he goes 1, 2, 3, 4 spots, which would be going up by 200s, right? So he's going up 800 meters. So 800 meters over 2 minutes. So to set up the speed, it would be 800 meters over 2 minutes. And if I simplify that, which I should, it would be 400 meters per 1 minute. I'll just say per minute. Okay, so 400 meters per minute. It's a really good speed, I think. Okay, Eric's speed between 0 and 3 minutes. So Eric, right here, he's the dotted line, right? We're going to do the same thing. 3 minutes is right here. So I want to find the slope of this line right here. So it looks like he goes 1,200 meters over 3 minutes. So let's figure that out. So 1,200 over 3 minutes, that would be 400 meters per second. So 400 meters, or not second, minute. Meters per minute. And then it wants the average speed for the whole trip. So the whole trip here. Now, to do that, we would find the distance over time, right? So for Eric, it'd be 1,600 meters over 9 minutes. And for Robbie, it'd be 1,600 over 10 minutes. So let's find Eric first. So 1,600 over 9. And let's simplify that. 1,600 over 9 is going to be a decimal. 177.7 repeating meters per second. So, or minutes. I always want to put that in second. So 177.7 repeating meters per minute. Not too bad, right? And then Robbie's average speed, 1,600 over 10 minutes, would simplify down to 160 meters per minute. Okay. So that's how you would set it up and do it. And again, it's just the distance over the amount of time. So if you have any questions, just let us know. We're here to help. We want to help, and we'll see you out there.